Okay, let's look at this example here. We have a particle, just a point mass, that moves along a horizontal path with the velocity. It has a function 3t squared minus 60 meters per second, where t is time in seconds. If it is initially located at the origin O, yeah, right here, determine the distance traveled in 3.5 seconds and the particle's average velocity and average speed during this interval. So how is this happen? Do you see there's originally over here, and then you go over here, and then you go this way. You see, many times when we look with we are applying vehicle dynamics, we would have to will have to do is do it in stages. Okay, so when the particle goes from here to here, let's say, and then the particle is on this other position here. So first of all, we need to put a set of coordinate system. We assume that this positive motion to the right measured from the origin O. See, so any measure from the origin O to the right is positive. If you travel here, the velocity is a function of time which is given. Yeah. The position as a function of time might be found by integrating the velocity, which would be b ds dt with t is equal to 0 when is equals to 0. So if you integrate this, we are integrating this function right here. Yeah. Remember the additive properties of integrals, that the integral of the sum is the sum of the integrals. What is the integral of 3 squared? Let's see, let's get those good brains working to integrate. On this side, the integral between, this is 0 and s is on this side, but the one over here, this would be 3t cubic divided by 3, right? Yeah. So that you get this term. And this other one, 6t, would be 6 times t squared divided by 2. 6 divided by 2 is 3. So you get this integrated here. Do you remember from your calculus class how to do that? So this is the distance traveled. In this case, we need to investigate the path of motion for this particular thing, although we have the description here. In this case, the velocity function that we see and reveals that for t between, I think the velocity function is over here, see? So if you plot this is what you get. So if this says that between 0 and 2 seconds, the velocity is negative, which means the particle is traveling to the left. And for t more than 2 seconds, the velocity is positive, and therefore the particle is traveling to the right. Also, b equals 0 at t is equal to 2 seconds. So the particle's position at t equals 0 and at 2 seconds and at 3.5 can be determined from the equation 1. So we start over here, but because of this, you see it's saying that when t is 2, which is 2 is times 2 times 2 is 8, right? This would be, if this is 2, then s, when is 2 seconds, s is 0. No, t is 2 seconds is minus 4 meters, and when t is 3.5 will be 6.25. So the path that is shown in this figure 6, 12.6a. So we will have that the distance total is 4 plus 4 plus 6, and the velocity would be the ds dt. In this case, we will have from t equals to 0 to 3.5. So we have to consider the variation of the velocity. So the change of the velocity will be between 3.5 and 0. So this is the, the position 612 minus 0. The average velocity is delta s over delta t. Delta is 6.12, delta t is 3.5, 1.75 meters. Then the average speed is defined in terms of the distance traveled. Okay, this would be the speed is ds delta t. So this would be 14.125 divided by delta t, and that is 4.04 meters per second. Here the acceleration is not constant either. Yeah. So you could plot the results here. You see, this is t and this is v from 0 to 10 and to 30, and you have, this is the velocity plot or the acceleration plot. So this is the, you can obtain it using the data from the previous pages and see the velocity is delta s over delta t, 20 feet per second, and the plot of the acceleration. You have to know the values of the velocity changes. So, and then you can see it here. So conclusion, you should examine the trajectory, and in cases of vehicles, when sometimes there's a collision, they hit other objects. So you have to divide the analysis between from one part to another and then from the other to the other. So that's why we're doing these exercises in preparation for those problems. All right.